All right, this is the Atwood's Machine Lab, the modified Atwood's Machine Lab. First, you have to set up your sensor. We put the photo gate in Digi 1, so you're going to go sensor, sensor setup. You're going to go Digi 1, and then you're going to set photo gate. Hit OK, and then that's set up. Hit OK again. And then what you're going to do is when you hit photo gate timing, because right now it's doing some different timing, we want the pulley 10 spoke. So we're going to hit that, and now it is all collaborated. If you look down here, I have this light right here, and if the light turns on, it means the laser is being blocked. So what I want to have happen is I want it to be able to flash as the laser is going through the spokes of the wheel. So I'm going to start off with no masses on the hanger, and the mass of the hanger, it actually says it right here, it's 50 grams is the mass of the hanger. I'm going to carefully slide that over the wheel and let it go. Now on my cart back here, I've got all the masses. Since this is the constant mass lab, we have all the masses that we need, including the cart, and how much the cart weighs is written here, 252.1. It's different for every cart. We have 4 250 gram bar masses, and then my masses here, these 4. Now, in order for me to keep a constant system mass, I'm gonna have to take trials and then move one of these off and then put it on the hanging mass down here. But I'm gonna do that when it's time, so not quite yet. So what we do, so that way it's changing the force, but not changing the system mass. So the first time we do it, as soon as I hit the green play button here, I'm gonna hit the green play button. As soon as I get the little curly, it's waiting for us to drop it. I drop it, it accelerates, I stop it, and make sure you don't have this slam into my pulley. Now, I hit stop on here, and I have 2 graphs, a position versus time and a velocity versus time. How can I get acceleration? From which graph?
Sorry, which was the graph again?
Velocity versus time or distance versus time?
Velocity
versus time, awesome. So I like this acceleration right here. I'm gonna highlight just part of that slope, and I'm gonna go analyze, curve fit. I'm gonna say velocity, because the slope of a velocity versus time graph is acceleration. And now your first acceleration point is m is equal to 0.34189. You're gonna put that into your spreadsheet as your first acceleration, and your force at that time is gonna be 50 grams, but 50 grams has to be in kilograms, and then times gravity, so times 9.81, and that's how much force caused that acceleration. So then you're gonna do that 2 more times. You're gonna get the acceleration 2 more times. After that, you're gonna move one of the discs over. You're gonna put it on the hanging mass, and then you're gonna run that 3 times. Take that data, then you're gonna do it again. We move one over, then you'll have 2 on the hanging mass, and until you have 5 independent variable increments. Cool? Okay. All right, guys. I look forward to seeing you and learning.